So today we will be covering topic Taylor series, error and approximation, and then Jacobian with properties. So I have given you this question. Expand tan inverse y by x in the neighborhood of 1 comma 1 using Taylor series. When I'm saying expand this function in the neighborhood of 1 comma 1, it means you need to expand this function in powers of x minus 1 and y minus 1, right? And you will be using formula number 2, right? So using Taylor series, we have f of x comma y is equal to f of 1 comma 1, a is 1 and b is 1. So f of 1 comma 1 plus x minus a is what? A is here 1 and b is equal to 1. So in that formula, we'll be putting a is equal to 1, b is equal to 1. So it is x minus 1, fx 1 comma 1. You need first order partial derivative with respect to x at point 1 comma 1 plus y minus 1, first order partial derivative with respect to y at point 1 comma 1 plus 1 by 2 factorial x minus 1 square fxx at point 1 comma 1 plus twice of x minus 1 y minus 1 f of x comma y 1 comma 1 plus y minus 1 square fyy 1 comma 1 and so on, right? So first I need value of function at point 1 comma 1. So when you are putting here y is 1, x is 1, so it would become tan inverse 1. Tan inverse 1. X be positive, y be positive, that means it is your first quadrant. So in first quadrant, you will be having value is equal to pi by 4. Right? Because x is positive as well as y is positive और दोनों positive कहाँ होते हैं? First quadrant में. तो first quadrant में tan inverse 1 would be plus pi by 4. So this is the value of f of 1 comma 1. Done. Next, you need partial derivative of tan inverse y by x with respect to x. So we are differentiating it and you'll be getting x square plus y square with negative sign. Now check it. Is it right? Those who have done it?
Yes, ma'am.
Yes,
Okay.
ma'am.
Done, beta. So now tell me what is the value of this derivative at point 1 comma 1?
Minus 1 by 2.
Minus 1 by 2, right? So we will be putting here a negative sign over here. Minus 1 upon 1 plus 1. So that is minus 1 by 2, right? Now f of y, Karthik, ID number 26.
Yes, ma'am.
f of y बताओ बेटा.
मैम सॉल्व कर रहा हूँ मैम.
किया क्यों नहीं बच्चे?
मैम
It was
समझ नहीं आ
homework.
रहा था.
क्या नहीं समझ आ रहा?
नहीं मैम, फॉर्मूला समझ नहीं आ रहा था.
तो बेटा फॉर्मूला नहीं समझ आ रहा था तो पूछना था ना.
नहीं मैम,
I
अभी
have
समझ आ गया, मैं करता हूँ.
explained it 3 times yesterday.
यस मैम.
फिर भी नहीं समझ आया तो पूछो तो सही. क्लास के बाद ही मैंने आपसे पूछा कि बेटा जिसको नहीं समझ आया प्लीज आस्क. जब भी कभी नेबरहुड, ये नेबरहुड से कंफ्यूज हुए थे?
यस मैम, यहाँ पे पता नहीं लग रहा था कि x माइनस 1 लेना है.
बट आई थिंक आई हैव एक्सप्लेन्ड यू.
या मैम.
Anyways, whenever it is written in the neighborhood of 1 comma 1, so it means you need to expand this function in powers of x minus 1 and y minus 1. If it is written like in the neighborhood of 0 comma 0, तो क्या बन जाएगा?
x माइनस 0 y माइनस 0.
हाँ, तो इसका मतलब सिर्फ x और y बचा ना?
यस मैम.
तो कब होता है x y की पावर्स में हम कब एक्सपैंड करते हैं? कौन सा फॉर्मूला होता है वो? क्या नेम देते हैं उसको?
x माइनस a वाली में मैम.
नहीं बेटा, आपने a की
X
वैल्यू
में.
फिर, हाँ, आपने उसको अब एक्स वाई की पावर में एक्सपैंड कर दिया. जब एक्स वाई की पावर में एक्सपैंड करते हैं तो क्या
Yes,
नाम
ma'am.
देते हैं उस पर्टिकुलर सीरीज को, पर्टिकुलर
मैक्लॉरेन
एक्सटेंशन
सीरीज.
को? यस, मैक्लॉरेन. तो जब भी कभी ऐसा लिखा है expand this function in the neighborhood of 0, 0 या फिर लिखा है obtain Maclaurin series for this, दोनों का मतलब सेम है. ठीक है, अगर ये लिखा है in the neighborhood of 1, 1, it means you need to expand the function in powers of x minus 1 and y minus 1. Is it clear now?
Yes, ma'am.
चलो. Jatinpreet. Jatinpreet. Ishita.
Yes, ma'am.
Beta f of y.
Ma'am, it's x upon x square plus y square.
It is x upon x square plus y square. And value of this derivative at point 1, 1?
1/2.
That is 1/2. Absolutely right, beta. Thank you. Similarly, we will be finding second order partial derivative. So fxx. Ria. Ria. Prabal. Harinderjeet.
Yes,
Harinderjeet.
ma'am.
fxx beta. Second order derivative.
मैम एक्चुअली मैम क्लास नहीं लगाई थी
क्यों नहीं लगाई थी?
मैम वो मैं रिसीव में गया था
तो बेटा रिकॉर्डिंग शेयर होती है आपसे, जैसे ना आप क्लास मिस करते हो, रिकॉर्डिंग शेयरिंग का मतलब ही यही है कि आप क्लास मिस करते हो तो इमीडिएटली यू हैव टू लिसन दैट, सो दैट कि अगली क्लास में आ रहे हो तो कुछ तो समझ आया हमें.
यस मैम आज पक्का देखूंगा मैम
यस, नो एक्सक्यूज फ्रॉम नेक्स्ट टाइम. आयुष 21. Ayush 21. Okay, anyone who has done it?
मैम मैं
Yes, ma'am.
बताऊं
Yes, it is.
मैम
It
टू
is.
एक्स वाई
Yes, beta.
मैम 2xy अपॉन
Upon.
एक्स स्क्वायर प्लस वाई स्क्वायर का होल स्क्वायर.
Right, absolutely right, beta. 2xy upon x square plus y square का whole square.
होल स्क्वायर
And value of this double derivative at point 1, 1.
मैम हाफ 1/2
That is again half. Thank you, beta. ID number, ये कौन था 42?
मैम
Next
17
Hitesh. 17, okay. Hitesh 42 ID, beta. F of y.
Minus 2xy.
You are not audible, बच्चे.
Ma'am.
Anyways, no issue, beta. No problem. You can mute yourself. Karthik. Karthik.
Yes, ma'am.
FYY बच्चे.
FYY. Wait, ma'am. Minus 2 xy upon x square plus y square whole square.
So that is f of y. Absolutely right, beta. Minus 2xy upon x square plus y square whole square. What is the value at point 1, 1?
Minus 1/2.
So that is minus 1/2. Correct. Next is f of xy. Who have done it? Anyone who want
Yes,
to give the
ma'am.
answer? बोलो बेटा
Yes,
Karnik.
ma'am. Y square minus x square upon x square plus y square whole square.
I think x square minus y square. No, it's y square minus x square, right? Right,
Yes,
huh?
ma'am.
It
Yes,
is
ma'am.
y square minus x square.
X square. And ma'am, value at xy is 0.
Yes, absolutely right, beta. And value is fxy at point 1 comma 1 is 0. Very good, beta. So we have evaluated first order derivative, second order derivative at point 1 comma 1. Now you need to put everything in our formula, that was this f of x comma y is equal to f of 1 1. We do have the value of this and all these derivative. So we are putting this in the formula. That is equal to pi by 4 minus 1 by 2 x minus 1 plus 1 by 2 y minus 1 plus 1 by 2 factorial. It's not plus beta here. 1 by 2 factorial x minus 1 square 1 by 2 plus twice of x minus 1 y minus 1 into 0, that is fxy, plus y minus 1 square into minus half, and so on. And finally, when you simplify it, and this would be your answer. Right? Now come to the next. You will do it and let me know what will be the values. Now, next question is expand x square y plus 3y minus 2 in powers of x minus 1 and y minus 2 using Taylor's series or theorem. Now tell me which formula we use. Which formula we use? Formula number 2, in which we have shown in the powers of x minus a and y minus b. So now you tell me what will be the value of a and what will be the value of b. We will compare these with x minus a and y minus b. Right? So I can rewrite it y minus of 2. So what will be the value of a and what will be the value of b? A is, compare it. A is what, beta?
1.
1.
1.
A is 1 and b is
Minus 2.
right? So we need to find out value of function at point a comma b, that is 1 comma minus 2, and all its first order second order derivative at the same point, right? So let us have first which formula we are using. This is the formula f of x comma y f of ab plus x minus a fx at point a comma b plus y minus b fy a comma b. Similarly, for second term, that is 1 by 2 factorial, x minus a whole square, second order derivative with respect to x, 2 x minus a y minus b, one with x and other with y, plus y minus b square f of y a comma b. And similarly, third term, a cube plus b cube, 3a square b plus 3a b square. This is square, right? So you need to find out value of function. What is a? A is 1 and b is minus 2. So first of all, find out this. F of x comma y function given, that is equal to x square y plus 3y minus 2. So find out first f of 1 comma minus 2. Put x is equal to 1, y is equal to minus 2 and calculate it. Hurry up. And then let me know what is the value of f of 1 comma minus 2. Yes, solve
Ma'am,
it.
ma'am, minus 7.
Minus 7. Let us check beta. It is minus 10.
Ma'am, minus 10.
No, ma'am, yes.
Okay, it is minus 10. Now, next we need fx at point 1 comma minus 2. So that is why first we need fx. Partial derivative of this function with respect to x, what it would be? 2xy. That's all. fx एक ही term है 2xy. Now find fx at point 1 comma minus 2. Tell me the value, hurry up.
Ma'am, minus 4.
Minus 4.
Minus 4. So value is minus 4. Go for f of y. Hurry up. First order derivative with respect to y.
-4.
Again -4?
Ma'am,
No,
No,
ma'am.
ma'am, it's 4.
4.
ma'am, 4.
It's 4. Okay, let us see. Uh, in next we will be seeing fy is equal to x square plus 3. So it is 4. Now find fxx.
Ma'am, it's -4.
It is -4. x का डेरिवेटिव फिर से लिया हमने x से तो it is 2y and y is what? -2. So 2 into -2 that is -4. Right? Isha beta, mute yourself. Thank you. Now next fy. Fy. What it would be?
0.
It is 0. So fy 0. Now what is left? fxy. Fxy. Find out.
2, ma'am, positive
Ma'am,
2.
2.
Ma'am, 2.
It is fxy is 2x and at point 1 comma -2 it is 2. Correct? Now f triple x would be 0. So f triple x value would be 0. F double xy that is 2 and value is 2. Then fxyy that is equal to 0. You can find out all the derivatives. It would be 0. And above that, this is your third order derivative. Right? Now you can observe every value is constant. So बाकी जितने भी higher order derivative होंगे that would be 0. So now you need to put all the values in that formula and that would become -10 plus 4x minus 1 plus 4y plus 2 minus 2 x minus 1 whole square plus 2x minus 1 y plus 2 x minus 1 whole square y plus 2. जो जो वैल्यूज आपके पास है वो आप पुट कर दोगे, जो जो वैल्यू 0 है वो सारी टर्म 0 हो जाएंगे. राइट? सो दिस इज योर आंसर.
Excuse me, ma'am.
यस बेटा.
मैम f of x y में हमने प्रोडक्ट रूल लगाया है.
किस में बेटा? fxy में.
Yes, ma'am.
क्यों प्रोडक्ट रूल क्यों लगाया? आपके पास fx फाइंड आउट किया था आपने?
Yes, ma'am.
ये fx था. ठीक है.
Yes, ma'am.
इसी को आपने क्या करना था? विद रिस्पेक्ट टू y कर देना था. तो आपने इसको जब विद रिस्पेक्ट टू y डिफरेंशिएट कर रहे हो तो कीपिंग x क्या होगा? कांस्टेंट. तो
Constant.
2x
Yes,
बच
ma'am.
जाएगा, y का डेरिवेटिव y से 1 हो जाएगा.
Yes, ma'am.
ठीक है. तो प्रोडक्ट रूल लगाने की जरूरत नहीं है वहां. fxy is equal to 2x. And then you need to find out
Okay, ma'am.
these derivative at point 1 comma -2. अब जितने भी डेरिवेटिव 0 थे, जिनकी वैल्यू 0 थी, उन सबको हमने यहाँ पर 0 पुट कर दिया फॉर्मूले में. यहाँ पर जितने भी डेरिवेटिव थे वो सब 0 हो गए. इसके आगे के जितने भी डेरिवेटिव्स थे वो सब भी 0 थे. दैट इज व्हाई in our answer we are not putting this plus so on. Whenever you are doing the question for polynomial either in single variable or two variable, you will not putting here plus dot. Why? Because we know that all higher order derivatives would be 0. because आपने देखा थर्ड ऑर्डर डेरिवेटिव आपके पास कांस्टेंट आ गया है, इसके बाद के सारे डेरिवेटिव 0. So you will not putting here dot. That means this is your complete solution. Right? In case of tan inverse cos जो आपने previous question किया था, in that tan inverse x derivative exist करते थे, तो हमने आपके आंसर में क्या किया वहां पर plus dot means it will go on. In case of polynomial, you will not put dot. Right? Now this is your homework. You will practice this question. Right? This is in terms of h and k. So you'll be using formula number 1. That is in the neighborhood of 1 comma pi by 4. Similar question. Here a is equal to 1 and b is equal to pi by 4. Third question. E power x log x plus y. Expand it. Expand it in powers of x and y. in powers of x and y. So that means you need to use third formula, that is Maclaurin series. You need to find out value of function and all its derivative at point 0, 0. And then put in the formula number 3. That is your Maclaurin series. Either question comes in this form, expand this function in powers of x and y, or obtain the Maclaurin series for this function. Both are the same thing. Third, if I'm saying the same question, expand this function in the neighborhood of the point 0, 0. In all three questions, solution would be same. Again, I'm repeating. First, expand e power x log 1 plus y in powers of x and y, one form. Second, expand e raised to power x into log 1 plus y in the neighborhood of point 0, 0. Third, obtain Maclaurin series for this function e power x into log into 1 plus y. In all three cases, your solution would be same. Ultimately, you need to obtain Maclaurin series for this given function. I hope I am clear to everyone. You will solve all these three questions. If you are having any doubt, then you will ask me. Now come to the next, error and approximation. So you tell me, what do you mean by error? What is error, beta? Anyone who can tell what is error? नॉर्मल एरर हमने किया है फिजिक्स की लैब में, हम एक्सपेरिमेंट करते हैं तो हम एरर फाइंड आउट कर देते हैं बिल्कुल एट लास्ट लाइन में. व्हाट इज एरर?
May I?
यस बेटा प्लीज.
Difference between actual value and calculated value.
Absolutely right, beta. Error is what? Actual value minus calculated value. Right? So here we will be doing this error and approximation as an application of Taylor series. Right? F of x comma y be a continuous function of x and y if delta x and delta y be the increment of x and y, then new value of this function would be f of x plus delta x comma y plus delta y, right? It is your new value and this is your old value, right? So we define this error in f, delta f is equal to new value minus old value, right? So I'm writing this is new value f of x plus delta x comma y plus delta y minus of old value f of x comma y, or you can say that this is observed value and minus actual value. That is your error, right? Now, what is this? F of x plus h. We have done the Taylor series for this. F of x plus h. I have told you what is h. H is a small change in x. So that is represented here delta x, comma y plus k. What is k? K is a small change in y. So that is represented with delta y here. So f of x plus delta x comma y plus delta y. Expand this using Taylor theorem and suppose that this delta x and delta y is so small and their product square and higher power can be neglected. So what we get delta f is equal to curly f upon curly x into delta x plus curly f upon curly y into delta y approximately. See, I'm expanding this. So what was your first term? F of x comma y plus h. What is h? Here h is delta x. Then curly f upon curly x plus k. What is k here? Delta y. Curly f upon curly y. Similarly, plus 1 by 2 factorial. Formula was h square. So we will be putting here delta x square curly 2f upon curly x square plus 2hk. So 2 delta x delta y f of x comma y plus delta y square, that is k square, and f of yy, and so on. Right? This is the expansion of this, and then minus f of x comma y. When we simplify it, this is negative and this is positive. It will be cancelled out. And as this delta x and delta y is very small, so we will ignoring the square because that is very, very small value. So delta x square, delta y square, and next delta x cube, delta y cube, and so on. So we are ignoring these terms. Right? So therefore we can write delta f is equal to curly f upon curly x into delta x plus curly f upon curly y into delta y approximately. Right? If your delta x is 0.01, so it is obvious now its square would be very, very less number and its cube would be very, very less number. So that is why we are ignoring all these terms. Right? And we are considering only this term. So error in function is given by curly f by curly x into delta x plus curly f by curly y into delta y approximately. So this is the formula for error in function. Similarly, if f is a function of several variables, let's say x, y, z and t, then error in function would be equal to curly f by curly x into delta x plus curly f by curly y into delta y plus curly f by curly z into delta z plus curly f by curly t into delta t. जितने यहाँ वेरिएबल होंगे उतने right? So this is in measured quantities, right? So this finding error and approximation in function, that is an application of Taylor series. You are applying here Taylor series and then you derive this formula, right? So error in function that would be evaluated by this formula. Let us have one example. Okay, before that, absolute error, relative error and percentage error. Absolute error is normally error जो आपने अभी निकाल दिया, let's say in terms of delta f, right? Delta f upon original value, delta f divided by f, that is divided by original value, it would become relative error. And when you will be multiplying it with 100, it would become percentage error, right? So this term would be clear: absolute error, relative error and percentage error. Relative error means absolute error divided by original value and percentage error is relative error into 100. So now this question is given to you. The diameter and the altitude of a can in the shape of right circular cylinder are measured as 4 centimeter and 6 centimeter respectively. The possible error in each measurement is 0.01 centimeter. Find the approximate error in the volume. Right? So आपके पास आपको find out करना है what? Volume of right circular cylinder. And what is the volume for cylinder? Pi r square h. Right? So let us suppose x be the diameter and y be the height. X be the diameter and y be the height. If x is diameter, then radius would be x by 2. So your volume would be pi x square by 4, h height is y, so that is y. So this is the formula for volume. So volume is equal to pi by 4 x square y. Absolute approximate error in volume. Formula is error in V is equal to V is a function of x and y. V is a function of two independent variable x and y. So formula would be curly V by curly x into delta x plus curly V by curly y into delta y. So now you can find out this curly V by curly x. So from here, curly V by curly x would be pi by 4 into 2xy. And what is Vy? Pi by 4 into x square. Right? So put all derivatives over here. Pi by 4 is common. 2xy delta x plus x square delta y. Right? Now x is given to you. What is x? Diameter. X is equal to 4. What is height? Y, that is equal to 6. And error in each, possible error in each measurement, that means delta x is equal to 0.1 as well as delta y is equal to 0.1. So you can put each and every value over here and you can get approximate error in volume, and that is given by 1.6 pi centimeter cube. Is it clear? Yes or no?
Yes, ma'am.
Yes, ma'am.
Clear now?
Yes, ma'am.
Okay, so now go for this question. If an error of 1% is made in measuring length and breadth of a rectangle, then the percentage error in the area of rectangle is what? Area of rectangle, area is equal to length into breadth, right? Percentage error in length and breadth is given 1%. Percentage error means error in x divided by its original value into 100, value of this is equal to 1. Similarly, delta y upon y into 100 is equal to 1. 1% error in is made measuring length and breadth. So this is given to us. So now we need to find out percentage error in area of a rectangle. So it means you need to find out delta A upon A into 100. I need this. Right? So from here, what is the formula for error in A? A is a function of two independent variable. So I'll be writing here curly A by curly X into delta X plus curly A by curly Y into delta Y. That is equal to curly A by curly A upon curly X value would be curly A by curly X.
1, ma'am.
1, why 1 beta?
Ma'am, why?
Yes, anyone
And
else?
by
1. Yes, it is y delta x plus curly A by curly y. That would be x
X dash delta.
delta y. Values. Now see what I need. I need to find out this, right? So now what is required? I need to divide this error in A with A. So I'm dividing by A on both sides. Okay, I'm writing it here. Delta A upon A is equal to y upon. Can I write here x into y? Okay, I'll write it later on. I'll be writing here A. I'm dividing with A on both sides. So y upon A into delta x plus x upon A into delta y. Is it right, beta? Then you need to multiply with 100. So I'm doing it on both sides. Into 100 into 100. Now, can I replace this A with xy? Yes or no? Yes,
Yes,
ma'am?
ma'am.
So I'm writing here. XY and at the place of other A also XY. This is xy. So this x to x cancel and here y to y cancel. So delta x upon x into 100. What is the value of this? Delta x upon x into 100.
Ma'am, 1%.
1. That is percentage error in x. Percentage error in length. That is given as 1%. Then plus delta y upon y into 100. Again 1.
Yes, ma'am.
Right? So what will be the answer? Answer must be
C.
what?
2%.
Answer is C. That is 2%. Is it clear? You need to find out percentage error in area. So first we find error in area. We know the formula of area. Area is equal to length into breadth. Then find the error in A, right? And this error in length, percentage error in length and breadth was given to you. So from here we have written like this, delta x upon x into 100 is equal to 1. Similarly, delta y upon y into 100. That is again a 1. After finding this error in area, we need to find out the percentage error. So that is why we are dividing this error with the original value and then multiplied by 100. Right? So answer is C. That is 2%. Now come to the next, that is Jacobian. How to define the Jacobian and where we use the Jacobian. Whenever you need to use the transformation of variable, whenever we are using, let's say I'm converting my Cartesian coordinates into polar coordinates. Do you know what are the Cartesian coordinates and polar coordinates? Yes or no? Anyone? Okay. So if I'm writing anything in terms of x and y, so these are your Cartesian coordinates. Cartesian coordinates. Have you listened like this? X is equal to r cos theta, y is equal to r sin theta. Have you read it somewhere? Or have you used anywhere? Yes or no? Please say yes or no. क्या हमने ऐसा कहीं सुना है? X is equal to r cos theta और y is equal to r sin theta?
Yes, ma'am.
Okay. So if you have heard it or you have used it, so these r and theta are known as polar coordinates. See, this is your x-axis, this is your y-axis, and you are saying this is any point having the coordinate x comma y in Cartesian coordinates, right? Now, this is your origin. Now I'm drawing a line from this point to the origin. So this distance is known as radius vector. And this radius vector making angle theta with this x-axis. So now I'm drawing a perpendicular from this point to on x-axis, right? So this is what? X coordinate, and this is what? Your y coordinate, right? Now, in this right angle triangle, if I'm writing this is base upon hypotenuse is equal to what? क्या होता है base upon hypotenuse? Cos theta. So this is equal to cos theta. So from here I can write x is equal to r cos theta. Right? Now come to this y. This is what? Perpendicular, and this is hypotenuse. So I'm writing here y upon r is equal to what? क्या होता है? Sin theta. Y upon r is equal to sin theta. So from here I can write y is equal to r sin theta. So what you did here, you have transformed Cartesian coordinates into polar coordinates, right? This was your Cartesian coordinate and these are polar coordinates. When the coordinates are represented in terms of r and theta, those are known as polar coordinates. In next unit, when we'll be doing multiple integral, then you will use all these transformation and Jacobian over there. But Jacobian is what? It is an application of partial derivative. So when you are converting Cartesian coordinates into some other coordinates, so you need their one value to equate them, that is known as Jacobian. Jacobian is a just a value, right? So where we use the Jacobian, whenever we are using the transformation of variable in multiple integral, then we use this Jacobian, right? So keep this mind. What is the use of Jacobian? I'm telling you today, and I'll ask you in next unit when we'll be doing multiple integration. So in multiple integral, whenever you are using the transformation of variable, to equate the integrals, we need one value that is known as Jacobian. Like I'm telling you, giving one example, how we use this Jacobian. Integration f of x comma y dx dy. This is your double integration, right? We will do it in next unit. You will be converting, for sake of evaluation or making your calculation easy, you are converting this Cartesian coordinates into polar coordinates. So you will be writing function in terms of r and theta into dr into d theta. But you cannot equate it like this. So for equating these integral, you need one value that is known as Jacobian. So this is the use of Jacobian. Whenever you are equating the integral, multiple integral, you are using the transformation of variable. To equate these integral, you need this value and that is known as Jacobian. Right? How we will use it? We will see in the next unit. Now come to the definition. If u and v are function of two independent variable x and y, u is a function of x and y, and v is also function of x and y. Then Jacobian of uv with respect to x and y. Jacobian of uv with respect to x and y is represented by the symbol capital J u comma v x comma y, or partial derivative u comma v partial derivative with respect to x and y. So either you can represent Jacobian with this or this, and defined by determinant curly u by curly x, curly u by curly y, curly v by curly x, and curly v by curly y. Value of this determinant is known as Jacobian of uv with respect to x and y. Right? uv are function of two variable x and y, then Jacobian of uv with respect to xy, that is defined by this determinant. Determinant curly u by curly x, curly u by curly y. You will be finding derivative of u with respect to x and y, put it in first row, then v with respect to x with respect to y in second row. Right? So you need to use this definition. So now I have given you the question, x is equal to r cos theta and y is equal to r sine theta. Now my question is, find the Jacobian of xy with respect to r and theta. Right? X is equal to r cos theta, y is equal to r sine theta. You need to find out Jacobian of xy with respect to r and theta. So you will be writing here determinant curly x upon curly r. फर्स्ट आपका फंक्शन है x, curly x upon curly r, curly x upon curly theta, curly y upon curly r, and curly y upon curly theta. Find out all the derivatives. Hurry up. and let me know. Curly x upon curly r. Yes, tell me beta, what will be the value of curly x upon curly r? Partial derivative of x with respect to r, keeping theta constant. Yes. Anyone? Partial derivative of x with respect to r, keeping theta constant. So what it would be?
Cos theta.
Yes, it is cos theta. इसका डेरिवेटिव करना है विद रिस्पेक्ट टू आर, तो cos थीटा वुड बी कांस्टेंट और r का r से डिफरेंशियल करेंगे तो 1 आ जाएगा. सिंपल. नाउ curly x upon curly theta. Now r is constant, r as it is, and derivative of cos theta is
Minus sin
minus
theta.
sin theta.
minus 90.
Good. Now in next row, curly y by curly r. So derivative of y with respect to r. Yes. Curly y upon curly r.
Sin theta.
Yes, it is sin theta. And then curly y by curly theta. It is r
R cos theta, ma'am.
r cos theta.
Cos theta.
Yes. Now evaluate this determinant. जल्दी से determinant की value solve करो. R cos square theta plus r sin square theta. So value would be what?
Ma'am, R.
R. Answer is R. Right? So Jacobian is R. You will use it many times when we will be doing in multiple integral. When we convert the Cartesian coordinates into polar coordinates, so you will remember it. What is the value of Jacobian? When we convert Cartesian coordinates into polar coordinate, the value of Jacobian would be R. Remember it, learn it, cram it. Okay, because you have evaluated it. Whenever we change Cartesian coordinates into polar coordinates, the value of Jacobian would be R. Let's say, for example, अगर मैंने इसी में change कर दिया आपका question and I'm putting here rho. X is equal to rho cos theta and y is equal to rho sin theta. Now I'm asking you the Jacobian of xy with respect to rho and theta. So what will be the answer? Yes, what will be the answer?
Ma'am, rho.
Rho, simple. Because we know that कि x is equal to r cos theta, y is equal to r sin theta है, तो आंसर r ही आता है. तो अभी r की जगह मैंने आपको rho दे दिया, तो simple answer would be rho. Right? So you will remember it. Whenever we change Cartesian into polar coordinate, value of Jacobian would be r. Right? Now, similarly, if you're having u, v, w, three function of three independent variable, then Jacobian of u, v, w with respect to x, y, and z is defined as you need to differentiate u with respect to x, y, and z. Keep all them in first row. Then partial derivative of v with respect to x, y, and z put in second row. Partial derivative of w with respect to x, y, and z put in third row. So this is how you define Jacobian of u, v, w with respect to x, y, and z. Right? Now let us properties of Jacobian. First is, if u and v are function of r and s, u and v are function of r and s, and further r and s are function of x and y. Right? So partial derivative or Jacobian of uv with respect to xy, like we have done in composite function. Jacobian of uv with respect to xy is equal to Jacobian of uv with respect to rs into Jacobian of rs into xy, like the chain rule. Jacobian of uv with respect to rs into Jacobian of rs with respect to xy. So this is your chain rule. Property number 2. If J1 represents Jacobian of uv with respect to xy and J2 is the Jacobian of xy with respect to uv, then J1 into J2 is equal to 1. This curly u curly v with respect to xy into curly x by curly uv is equal to 1. Property number 3. If u1, u2, u3 be the function of x1, x2, x3, the necessary and sufficient condition for existence of functional relationship of the form function of u1, u2, u3 is equal to 0, it means we need to check whether they are functionally dependent or independent. Right? If they are dependent, it means there must be some relation. If they are independent, it means there is no relation between them. Then what is the condition for checking their relationship? Is Jacobian is equal to 0. If Jacobian of UVW, U1, U2, U3 divided by x1, x2, x3 is equal to 0, it means they are functionally dependent. Right? And if it is equal to 0, they are dependent, it means there must be some relation. Right? So to check functional dependency, you need to find out Jacobian. Property number 4. If u is a function of x, v is a function of x and y, and w is a function of x, y, and z, then you need to find out Jacobian of u, v, w with respect to x, y, and z. You find out करना है. If u is a function of x, this is your Jacobian. ux. Derivative of u with respect to x, it would be ux. Derivative of u with respect to y, it would be 0. Derivative of u with respect to z, it would be 0 because u is a function of x only. Similarly, v. V is a function of x and y. So you will be having here vx and vy, and that is 0. And here wx, wy, wz. Right? So what is the determinant of, what is the value of its determinant, beta? What will be the value of determinant? Find out.
It's ux, vy, wz.
Right? ux into vy into wz. And you know that in case of upper triangular, lower triangular, or diagonal, in all three cases, determinant is the product of diagonal entries. Right? So answer would be curly u by curly x into curly v by curly y into curly w by curly z. So for example, if I'm saying u is equal to x, or v is equal to x square plus y square, or w is equal to x, y, z. Right? And I'm asking you Jacobian of UVW with respect to x, y, and z. Right? So I'm putting here value in this determinant. So at the place of curly u by curly x, it would be 1, and then 0, and then 0. Vx, that is 2x, Vy, 2y, that is 0. And here it is yz with respect to x, it is xz, and then here xy. Right? So when you'll be solving, it is what? Ux, directly you can write here 1 into 2y into xy. So that would be your answer. Right? So if you have function in this form, so directly you can write this answer. Now come to the next example. If r is equal to under root x square plus y square and theta is equal to tan inverse y by x, then evaluate curly r theta curly xy. Means Jacobian of r theta with respect to x and y. So now you need to find out curly r by curly x and curly r by curly y. Find it out, hurry up. Derivative of r with respect to x, derivative of r with respect to y.
Ma'am, 1 upon 2 under root 2x.
1 upon 2
May ma'am multiply under root 2x.
और 2x नहीं करना हमने x square plus y square raised to power 1 by 2 ये आपका फंक्शन था r तो आपने इसको डिफरेंशिएट करना है विद रिस्पेक्ट टू x so you will be doing 1 by 2 x square plus y square raised to power minus 1 by 2 so we are writing it denominator into derivative of x square that is 2x so x would be cancelled out and that is x upon under root x square plus y square right similarly curly r by curly y that would be y upon under root x square plus y square done हो गया now theta is equal to tan inverse y by x we have evaluated in I think previous question Taylor series curly theta by curly x and curly theta by curly y so it would be theta by x is minus y upon x square plus y square and curly theta curly y is x upon x square plus y square tan inverse y by x 1 upon 1 plus y square upon x square into derivative of this with respect to x minus y upon x square. So after simplification, you'll be getting this. And similarly, you can find this. So now we do have the formula curly r by curly x, curly r by curly y, rx, ry, theta x, theta y. Put all the values over here and evaluate the determinant. Do it, hurry up. Put all the values of derivatives and evaluate it. Yes, done beta? Yes, who will tell? Yes, Yashika, have you done beta?
Doing, ma'am.
Okay, do it. Yes, Niharika,
Yes, ma'am.
done beta?
No, ma'am, I'm just doing.
Okay, do it, do it. You need to find out just determinant beta. All values is given to you. Okay, I'm showing you. You have put all the derivative over here and then evaluated it. Answer is x square plus y square. Multiply this x square plus y square power 3 by 2 minus plus y square upon x square plus y square power 3 by 2, and ultimately answer is 1 upon under root x square plus y square. Right? Or you can say that this is 1 upon r. This is r is equal to under root x square plus y square. So that is equal to 1 by r. Now you can observe it better. R is a function of x and y. Theta is again function of x and y. You need to evaluate this, right? And before that I have told you, x is equal to r cos theta and y is equal to r sin theta. And then you have evaluated Jacobian of xy with respect to r and theta. When you have evaluated this, answer was r. Jacobian of xy with respect to r and theta, answer was r. Then from here, you'll be writing squaring and adding. So you write r is equal to under root x square plus y square. When you are dividing this, sine theta upon cos theta, it becomes theta is equal to tan inverse y by x, and you are evaluating answer is 1 by r. So one property I have told you, this into this, r into 1 by r, that is equal to 1. One property is proved. Which one? Property was this. J1 is the Jacobian of uv with respect to xy. J2 is the Jacobian of xy with respect to uv. Then product of Jacobian is equal to 1. Right? Now come to the next question. If u is equal to yz upon x, v is equal to zx upon y, and w is equal to xy upon z, then show that Jacobian of uvw with respect to x, y, and z, that is equal to 4. So this is the definition. You need ux, uy, uz, vx, vy, vz, wx, wy, wz. So find out ux, uy, uz. Hurry up. Just take 1 minute. जो सबसे पहले कर लेगा फटाफट आंसर बताएगा मुझे. Tell me ux. Curly u upon curly x. What it would be? Hurry up.
Minus yz upon x square.
Minus yz upon x square. Correct. Curly u by curly y. Curly u by curly y. Very simple.
And z over x.
Correct. Z by x. Curly u by curly z.
Y by X.
Y by x. Good. Now next, curly v by curly x. Curly v by curly x.
Z by Y.
Z by y. Correct. Curly v by curly y.
Minus
Minus
Z
zx y square.
upon Y square.
Correct. Minus zx upon y square. Curly v by curly z.
X upon y.
X upon y. Correct. Curly w by curly x. Third row. We need all three derivatives. Curly w by curly x.
Y by
Y
Z.
upon z.
Correct. Curly w by curly y.
X by Z.
Right. Curly w by curly z.
Minus XY by Z square.
Evaluated all the derivatives. Put all the derivatives in this determinant. Put all the derivatives in determinant and then solve it. So this is your determinant. So you can take 1 by x outside from first row, 1 by y from second row, and 1 by z from third row. So 1 upon x, y, z, and then simplify this determinant. Right? After simplification, you will be getting your answer as a 4. You will do it yourself. Right? Now, these are your practice question. You have to solve it, right? First is, look at the question number 3. x is equal to r cos phi and y is equal to r sin phi. Then what is the value of Jacobian of xy with respect to r and phi? Who will give you the answer? What will be the value of this Jacobian?
Ma'am,
R.
R.
R. That is very good. Answer is R. Because वहाँ क्या था? सिर्फ थीटा था और थीटा हो या फाई हो जैकोबियन पे उसका कोई इफेक्ट नहीं था, right? So what is this? This is the case of polar coordinates. Cartesian coordinates are converted into polar coordinates. Then value of Jacobian would be R. तो आंसर आपका R आएगा. Now come to the second question. X is equal to rho cos theta, y is equal to rho sin theta, and z is equal to z. Then you need to find out Jacobian of x, y, z with rho, theta, and z. You will simplify it and you will check whether you are getting answer rho or not. These are known as cylindrical coordinates. Because cylinder कैसा होता है आपके पास? ऐसा. Sorry, both are equal. ऐसा सर्कल सिलेंडर होता है. सिलेंडर के किसी भी पॉइंट को, लेट्स से ये वाला पॉइंट है, इसके कार्टेशियन कोऑर्डिनेट्स आपके पास है x, y एंड z. जब हम इट इज अ 3 डायमेंशनल, जब हम इसको फ्लोर पे देखेंगे तो z तो z ही रहेगा और xy का रिफ्लेक्शन xy में आ जाएगा और xy को आप फिर पोलर में चेंज कर देते हो. तो इट इज rho cos theta, rho sin theta, and z would be z. In that case, again your Jacobian is equal to r or rho, because r की जगह पे क्या है अभी rho है. So these are your cylindrical coordinate, and these are known as spherical coordinates. So you need to find out the Jacobian of this, Jacobian of this. And fourth question, if u is equal to this and v is equal to this, show that u, v are functionally related and find their relationship. If they are related, it means Jacobian of u, v, u is a function of xy, v is also a function of xy. So you will be finding Jacobian of uv with respect to xy, and that must be equal to 0. If it is equal to 0, it means they are dependent to each other. And if they are dependent, then find the relation. You know that v is equal to sin inverse x plus sin inverse y. That is equal to sin inverse x under root 1 minus y square plus y under root 1 minus x square. और ये क्या है आपके पास? That is u. Sorry. Yes, that is u. So it would be v is equal to sin inverse u. V is equal to sin inverse u and u is equal to sin of v. So this would be your relation. Is it clear? Whenever you need to find out the dependency of function, you check Jacobian of those function with respect to independent variable. If it is equal to 0, it means they are dependent. If it is not equal to 0, it means they are independent. And if it is 0, they are dependent, and then you need to find out their relationship. Right? So that's all for today. Any doubt, beta?